Hi everyone, welcome to today's video. So today we're going to be introducing rational numbers, and we're going to be identifying types of numbers within those categories, and then that's also going to involve looking at converting between fractions and decimals. So we're going to kind of start with identifying rational numbers, okay? So let's look at what we're asked to do here. We want to identify each number as a rational number or not a rational number. If it is a rational number, if it is rational, we're going to identify it as either an integer, a terminating decimal, or a repeating decimal. So something that's going to be really helpful when we're doing this is this note sheet. We can classify numbers lots of different ways. So what we're focusing on in 7th grade is the umbrella category of rational numbers. So rational numbers are going to be split for us into ultimately 3 different categories. There's going to be integers, which we have here, and then we're going to have fractions, which can be expressed as decimals, and then there's going to be 2 categories within that. Okay, so a general important thing to know, just to get off the bat, basically every number you've ever interacted with in your life so far has been a rational number. There's only one exception to that, probably, which is pi. What's special about pi is that pi goes on forever and it has no repeating pattern. 3.141592653589793232846 forever, and there's never any pattern that forms with those decimals. Okay, so that's a special example of called an irrational number, a number that's not rational. So we're not really focusing on that at all in 7th grade. But we're going to be working with rational numbers, which is basically any number outside of that. So that includes integers. Okay, integers are positive and negative numbers and 0 that have no fractional or decimal parts. So 0, 1, 2, 3, 4, 5, those are all integers. And then the negative, or the opposite of all those numbers, are also integers. -1, -2, -3. So integers is a type of rational number. And then we have fractions, right? So those are everything that's not integers. There's fractions, there's decimals, there's things that make it kind of messy. Okay, and we're going to split fractions up into 2 different categories: terminating decimals and repeating decimals. Okay, we're looking here at terminating. A terminating decimal is a number whose decimal form ends, or there's a finite number of digits. So some examples would be the number 1/4 and 0.25. And then here we have -6 3/8. In decimal form, that's -6.375. So that's a number whose decimal form ends, and it's negative here, but that doesn't change anything. And our last option is a repeating decimal. So a repeating decimal is also in this realm of a rational number. It's a fraction. It's a number whose decimal form repeats the same sequence of numbers forever. Okay, so for example, we have 1/3. Is 0.333333333 forever. Okay, that little bar, it's called a vinculum. It means we have 3's going on forever. This is different than pi though, just to be clear, because we have this repeating pattern. Pi has no repeating pattern. Okay, then we have -6 and 23/99. So that ends up being equivalent to -6.2323232323 forever. Okay, so we would write that as -6.23 repeating. Again, that's a repeating decimal. It's a type of rational number. All of those numbers are rational numbers. A strong definition of a rational number is a number we can write as a fraction of integers. So if we look at all these, like 1/3, that's a fraction of the integers 1 and 3. And now we're going to go to some examples to classify them. So our first one, identify 2/5 as rational or not. If it's rational, identify it as an integer, a terminating decimal, or a repeating decimal. Okay, so first we need to ask ourselves, is this rational or not? So yes, this is rational. A rational number can look like a fraction of integers. If I go back to my notes, 2/5, it's a fraction. And fractions are a type of rational number, so we know it's a rational number. Then though, since it's a fraction, we need to decide, is it a terminating decimal or a repeating decimal? Okay, so how do we do that? We need to convert 2/5 into its decimal equivalent. So now I'm actually going to go to a different slide to talk about the ways we can do that. All right, so we want to figure out what is 2/5 in decimal form. We're going to have kind of our mini lesson on converting from fraction to decimal form. So the huge key concept from today, from this part of the lecture, is that a fraction bar means division. When you see a fraction bar, that means division. With a calculator, this kind of work is pretty straightforward. I have 2/5, which is 2 divided by 5. So I can take any old calculator and I can do 2 divided by 5. And I'm going to get 0.4. 0.4 is the decimal form for 2/5. Again, all I did is I took my numerator 2 and divided by that denominator of 5, and I got 0.4. Eventually, I'm going to kind of come back and show you how to do that without a calculator. Okay, so we found that 2/5, what's the point of doing that? We found that 2/5, this is equal to 0.4. So then we need to decide, well, is this an integer? No, we already said it wasn't an integer. It's a fraction, so is it either a terminating decimal or a repeating decimal? Okay, well, it's always good to go back to our chart. A terminating decimal means a number whose decimal form ends or has a finite number of digits. That's different than our repeating decimals, where we have our repeating lines. Okay, so is 0.4 the repeating decimal or is it a terminating decimal? It's a terminating decimal. It ends. Right, we see it at 0.4, it's over. So this is a rational number, and more specifically, it's a terminating decimal. Awesome. All right, let's go to number 2. We have negative 0.14 repeating. All right, well, first, is this a rational number? So basically, right, is there pi in it, or is there some weird thing where a number is going on forever with no repeating pattern? This number does go on forever, but there's a repeating pattern. This is negative 0.141414141414 forever. That's a repeating pattern. So that means that it is still rational, a repeating decimal. All right, now let's look at 3. We have 2 pi. So is 2 pi going to be rational or not? The second we see pi, we should be pretty alarmed and think this probably isn't a rational number. So if I type it into my calculator, I'm going to get 6.283185307118. And this looks, maybe you'd think this stops, but that's just because the calculator's rounding, which is why you have to be careful sometimes with calculators. But if we have pi in any form, that means we're going to have an irrational number, not rational. It goes on forever and there's no pattern. Okay, and then we have negative 1/3. All right, let's get this in our decimal form. So this is equal to negative 1, and then we need to take care of the 1/3. So we need to figure out what is 1/3 as a decimal. This is a good thing to know. It was on my reference sheet. You could also go to our calculator, 1 divided by 3. That's 0.3 repeating. So this is negative 1.3 repeating. Negative 1.33333333 forever. Then from there, is this a rational number? And if so, is it a repeating decimal, a terminating decimal, or an integer? I'm going to have you try. Take a look here if you need to. Okay, so we should have gotten rational and a repeating decimal. Okay, it is a rational number. It goes on forever, but there's a repeating pattern. That 3 repeats forever, so that makes it a repeating decimal. All right, also I'm going to have you do 5, so I have negative 100. Okay, so you should have gotten a rational and an integer. It's an integer because there's no decimal or no fraction. Makes no difference that it's negative. Okay, and then lastly, you have 4.22. Okay, so 4.22 is rational and it's a terminating decimal. Something that could have tripped you up here is we have 22, so there's like that repeating thing. Okay, but a repeating decimal has to repeat and go on forever. So we either need a repeating bar or we need like 22 dot dot dot, meaning that it's going to be 2 2 2 2 2 2 2 2 2 2 forever. But that's not what this says. Awesome, good job. So the last thing we're going to do is just look at one example of how we can go from a fraction to a decimal by doing long division. Okay, so here we have our example. We're going back to this. We had 2/5. Using a calculator, we did 2 divided by 5, and that was equal to 0.4, or 4/10. So now we could do that without a calculator using like decimal long division. It's not the most fun thing, but for something like 2/5, it's not too crazy. So with long division, we always take the dividend, which is the number that is being divided, and we put that inside our long division bar. So I have like a 2 right there. Okay, and I'm dividing it by my divisor. That's 5. That's what goes to the left. And then the number I get up here, that's going to be my quotient, which is a math word for my answer for division. Okay, so the way generally long division works is I'm going to say, okay, how many times does 5 go into 2? Well, 5 doesn't go into 2 anytime, 0. Okay, so I'll actually put a 0 here, right above the 2. But then I didn't get very far. So what you can do is 2, that's the same as 2.0, the same as 2.00. Adding zeros after a decimal point doesn't change anything. So I'm just going to make it 2.0 because it's actually all we're going to need here. So then I look at this and say, how many times does 5 go into 20? Thinking about the multiples of 5. There's 5, 10, 15, 20. So that's 4. 4 times 5 equals 20. So that means I'm going to put 4 right here. Okay? And then I will bring up my decimal point, because for when you're dividing with decimals like this, you always just bring the decimal point directly straight up. Okay, and then we would continue to do 4 times 5 then. You do 4 times 5. That's equal to 20. And we subtract 20 minus 20. And that's going to give us 0. Once we get 0 down here, that means we're done. We've fully and correctly divided. 2 divided by 5 is 0.4. Okay, like we can already see. Great job, everyone.